the last example, and for some reason I didn't start the. My last. All right. So this is the last. So it's so we just did an example of a complete application where we set it up and it was the unbounded case. So this is an example of the bounded case. All right, which again we're going to set it completely up, graph it, find the quarter points, determine my optimum solution. All right, so we have a store that sells two different types of coffee blends, an economy blend and a deluxe blend. All right, one package of economy blend, so one package of the economy contains 1 pound of the Colombian coffee, 3 pounds of the house blend. All right, one package of the deluxe contains 2 pounds of the Colombian, 2 pounds of the house. All right, they have up to 300 pounds of the Colombian and 480 pounds of the house. And the store plans to make a profit of oh, that's a little dark. Make a profit of $2 for each packet of economy, $3 for each packet. So for every time they sell they marked it up to cover their cost. So for each packet of economy, they make $2 in profit. For each packet of deluxe, they make $3 in profit, right? Because they marked up the deluxe a little higher. That's why they call it deluxe. How many packages of each should they make in order to get the largest profits? All right, write the variables and the objective function, and then I'm assuming the next thing I'm going to ask is constraints. Yeah. All right, so we'll start with the objective. So the objective is to optimize profit and the variable. So each package, how many packages of each? So I'm going to let X represent the packages of the economy blend. So the number of economy packages. Y is the number of deluxe packets. It's a weird Y. All right, the objective is to maximize profit. So I'm going to let P be my profit. And so X represents the economy packets sold. Y represents the deluxe sold. For each economy, they make $2 in profit. For each deluxe, they make $3. So that's what we want to optimize. So again, we're going to kind of hold on to this. And after we find our constraints, graph it, find our corner points, then we'll come back to the objective equations. All right, so next the constraints. So first of all, I'm going to write down those greater than or equal to 0 because that has to be true. They have to have more than 0 packages of the economy. More than 0, right? No negatives. Right? It has to be positive or 0. They can either sell positive numbers or 0 amounts. They can't have negatives. So again, that's important. So I usually write that down first so I don't forget. All right, then it comes from what I am limited by, and so what we are limited by is how much. So they blend what they call the Colombian coffee, so what they get from the Colombian people, and then what they call the house brand. All right, and so they have so much Colombian coffee to blend with so much of the house brand. The economy has more of the house than of the Colombian, which I'm assuming the Colombian must be the tastier coffee. The deluxe has the same amount of house as it does Colombian. Right? And so it has to do with how much they have, how many pounds of each type in the blend that they can have, right? Because I've got so much Colombian and so much house. So that's my limiting amount. I can't use more than I have. All right, so they have up to 300 pounds of the Colombian coffee. So up to 300 pounds of the Colombian coffee. And 480 of the house. So up to 480 pounds of whatever their house coffee is. Right. Up to means you can't blend more than you have, right? So on their shelves, They have 300 pounds of the Colombian and 480 pounds of the house. So I can use it all up, or they could use less than all of it up if they, again, don't think they're going to sell as much. And so the blends have to be less than the 300 and the 480, or equal to. And so less than or equal to 300, less than or equal to 480. And so remember, it's the equation part that has to be less than. My equation of deluxe coffee and economy coffee has to either equal the amount of coffee I have or be less than the amount of coffee I have, right? I can't go over it, so that's why it's the less than case. And so I've got my X and my Y, which I have to fill in with my Colombian coffee, and the same thing for the second one. I've got my X and I've got my Y. And so remember, X represents the economy, Y represents the deluxe, which I believe is the yellow line is the economy, blue line is the deluxe. Alright, so the first equation stands for the Colombian coffee they have. So they have up to 300 pounds of Colombian coffee, so when they blend it, they can only use up to 300 or fewer. And so this has to do with the Colombian. So when they put together the economy, well, how much Colombian do they use? Well, the economy uses 1 pound of Colombian, so 1x. And I'm going to write in the 1 times x right now. I'll probably end up erasing that because 1x is just x. And then the Colombian for the deluxe is 2 pounds of Colombian, so this is 2. Alright, now the house coffee. So now I'm looking at the house coffee. So again, they have up to 480. So when they add the two different types of packages together, it has to add up to 480 or less. The economy takes 3 pounds of the house, and the deluxe takes 2 pounds. So 3 for X, 2 for Y. Alright, and then the check that I've done it right is the X represents the economy. X represents the economy. And so my economy, the first line, should represent 1 and 3. And it does, 1 and 3. Colombian house. Right? 1, 3. The 1 goes with the Colombian, the 3 goes with the house. The deluxe should have 2, 2. And each of those should go with each one. 2 for the Colombian, 2 for the house. So it checks. Right? I am going to erase the lines underneath because I think it just makes it cumbersome. You can leave them or not write them at all. And I'm probably going to erase the 1. Just because I think it's a little neater not to have it. Alright, so there are my constraint equations, which I have to then graph, find my feasible region, and go from there. And these are both less than, so I know it's the bounded case, because I'm going to shade above them. Right? I'm going to keep the below, shade the above. And also, I have to be positive, so I have to stay in the positive region. Alright, so first one, x plus 2y equal 300. I'm going to find my intercepts. Alright, so x equals 0, 2y equals 300, divide by 2, so y equals 150. Alright, y equals 0, x equals 300. That was an easy one. Alright, so I've already kind of got it scaled here for you. So 0, 150, and 300, 0. So 0, 150 puts me here. Right, that is the 0, 150 spot between 140 and 160. And then 300 puts that over here. Connect my dots as best as I can. So there's my first equation, which represents the x plus 2y equals 300. And I know I'm going to shade above it because I want to keep the less than. So I'm going to shade above it. The test for 0 would come out true, right? 0 is less than 300. All right, now the second equation I'm going to draw in red. So equation 2. 3x plus 2y equals 480. So same thing. So x equals 0, I get 2y equals 480, so y equals 240. And then when y equals 0, 3x equals 480, 160. Alright, so 240, 0, 240, 160, 0. So 0, 240 puts me way up here. 0, 240, and then 160. dots as best as I can. Ah. Alright, that one kind of got way out of hand. I always have trouble with this angle. I think it's because I'm right-handed and it wants to go left. Alright, I'm going to have to just find this the hard way. So 3x plus 2y equals 480 is the red. Shade above, because again it's less than, so the 0, 0 is going to be a part of the equation, right? Both of them are less than, so 0, 0 is going to, so I'm going to shade above, because I don't want above, I want to keep below. And then also keep in mind, remember I've got these boundaries, which is my x equals 0 and my y equals 0. So this is going to be a bounded case, right? Because I'm on this side of each of my x-axes and y-axes. And then I'm above both of these lines. So shade everything above both of my lines. And it's a bounded region, so it is bounded. Right, it's completely surrounded in gray, right? Because I'm bounded. There are 4 corner points. There's the first corner point here at A at the origin, which I know what that is. There's the corner point here. I'll call that B. That's the point 0, 150. This is the one I'm going to have to figure out. And then D, I know is, I can't quite see it there, but I know that's 160, 0. Alright, so C is the only one where I have to figure out. So C, I'm going to go ahead and do that before I get to my table. So what's C? Well, it's where the blue line and the red line intersect, so I have to solve those two equations. So x plus 2y equals 300. 3x plus 2y equals 480. I just use a matrix and my RREF. So give me a second while I plug those into my matrix of my calculator. Alright, when I plug them in, I get 90 for x, 105 for y. So 90, 105. So the point C is at 90, 105. I wasn't horribly far away from on my sketch there. Alright, so go to my table. I'm just going to go ahead and fill my table in. Alright, so A, B, C, D. My A was 0, 0. B was 0, 150. C I found, which was 90, 105. And D was 160, 0. Which again, C was the only one I had to check. The rest of them I knew because I used them to graph, right? So I didn't really need to check those. All right, the objective equation, which I remember was profit, 2x plus 3y, and I want to maximize. So plug those in. So 0, 0 is going to give, and it should make sense. They don't sell any, they don't make any profit. All right, 0 for x, 150 for y. That's going to come out 450. 90, I'm going to guess it's the 90, 105, but I have to check it out, make sure it is. So 90 for x, 105 for y, that comes out 495, and then the last one, 160 for x, which comes out 320 because it's 0 for y, and that is my maximum. Alright, so my optimum solution is they get a maximum profit of 495 if they sell 90 of the regular, or economy, right? No, regular was regular. Regular. And 105 of the deluxe. I don't know if it was regular or economy. Economy. I was right the first time. Of the economy and 105 of the deluxe. Alright, so if they sell 90 packages. So if they sell 90 packages of the economy and 105 packages of the deluxe, they'll make a profit of $495, and they won't exceed how much material they have, right? They only have so much coffee, and they'll stay within the bounds of their coffee. All right, so that's the last example. So there is the finished, the linear of your programming. So I did an example of a bounded and unbounded where we kind of put it all together. Next one is kind of try on your own. This is a lot of times how we'll ask it. We'll ask you to set one up. And that'll be sort of one types of questions you'll get. And then you'll be asking a different question where we've set it up for you. And then you'll ask to find the feasible region and the optimum solution. So it'll be done more in pieces because these are such big, long problems. You mess up one part, you mess up the whole thing. And so we'll separate them. So I'll ask. So this is actually one to do on your own, kind of like what we like to ask on the quiz and the final, where it's just asking you to set it up, kind of like I did when I started this out. And that's one type of question. And then another type of question would be, I already set it up for you, so you have the right setup, and then you have to go and solve it. Alright, so this is one to do on your own. See if you can't find the objective and the constraint. One of these gives the correct constraints, one of these gives the correct objective, and see if you can't find that, and I will post the answers later in the week. Alright, finishes up chapter 5. Only chapter 4 left to go. We're almost done, and chapter 4 is a very short chapter.